Hello, welcome back. Today we're going to be talking about graphing functions from a table. The objective is that by the end of this video, you should be able to graph a linear function using a table. To understand what a graph is, we need to understand what a solution to an equation in two variables is. Please note the following words. The word solution to an equation in two variables. So that means we're going to have typically an x and a y, and we're going to be finding a solution to that equation. Since we have an x and a y, our solutions are going to look like ordered pairs, and the ordered pair should make the equation true when substituted in for the variables. So is negative 3, 2 a solution to 3x minus 4y equals 6? Well, the negative 3 is x, the 2 is y, and we need to substitute these values in for x and y to find out if it is indeed a solution. Let's check it out. We get 3 times negative 3 minus 4 times 2, since y is 2, equal to 6. 3 times negative 3 is negative 9, minus 4 times 2 is minus 8, equal to 6. Negative 9 minus 8 is negative 17, equal to 6, which is not true. So no, negative 3, 2 is not a solution. Please try the one below, pausing the video, and press play when you're ready to see the answers. X is negative 1, y is 5, so we put 5 equal to 2 times negative 1 plus 7. 5 should be equal to negative 2 plus 7, and negative 2 plus 7 is positive 5. 5 equals 5, so yes, negative 1, 5 is a solution to this equation. Now let's take a look at a graph of a linear equation in two variables. Again, the key words are graph, meaning we're going to have a Cartesian coordinate system, or the coordinate plane, of a linear equation, means our equation is going to create a line, two variables, meaning we're going to have an x and a y. A graph of a linear equation in two variables are all the solutions to the equation drawn on a coordinate plane. Again, it's going to create a line. So, for example, the graph of y equals x is below, and all the points where y and x are equal make a line. This is a linear parent function. When we graph the points from our typical table, we ended up with this. What I want you to know is that the graph actually includes every single point between those points and extending out in all directions. Why? Because every single one of those points represents where y is equal to x. When you bunch all those points together, it should create a straight line. Before we can talk about graphing, we need to talk about an inequality symbol. I know you've done these in the past or used these in the past. However, just to make sure there's no confusion, let's review these symbols together. This is an inequality symbol right here. It's made up of two parts, a small pointy end and a larger open end. The small pointy end always points to the smaller number. The larger open end always points to the larger number. If you happen to have a line underneath of your inequality symbol, it means that the numbers can be equal, such as 4 less than or equal to, say, 5. We would read this as 4 is less than or equal to 5. I have an example, and we're not going to be using numbers so much as variables compared to a number. So x bigger than or equal to 2. This means x can be any number bigger than or equal to 2. We're going to run through a few of those together. X is less than or equal to 5. This means that x can be any number less than or equal to 5. It can be 4, 3, 2, 1. It can also be 5 itself, because x represents any number that's less than or equal to 5. The one that can be confusing is this one right here. Notice that x is between the two numbers. The way this is written means that x can be equal to or between 2 and 5. So I've got a series of questions with a different example for you to answer on your own. Please look at the inequality and answer the questions. Please press pause, and when you're ready to see the answers, please press play. Can y be 10? No, because y has to be between negative 3 and 7. Can y be 0? Yes, because y has to be between negative 3 and 7. 0 is between negative 3 and 7, so yes, this is true. Can y be negative 5? No, because negative 5 is not between negative 3 and 7. Last question, can y be 7? The answer is yes, because y is less than or equal to 7. The little line underneath the equal to sign, or underneath the inequality symbol, means that it can be equal to 7. So remember, if y is between these two symbols and they have the lines underneath, it means y has to be between or equal to those two numbers. Looking at the last bit that I'd like you to think about, list the whole numbers that x can be equal to. And can x be equal to any other numbers? Well, the whole numbers means like 0, 1, 2, 3, 4, 5, so on and so forth. So let's list them. 0, 1, and 2. Can x be any number other than these? The answer is yes, because since x has to be between 0 and 2, x can also be 1.5, 1.3, 0.1, 0.2. It includes all of the decimals between 0 and 2 as well. In the past, we graphed an equation that looked like this. Y is equal to 2x plus 1, and our domain was negative 2, negative 1, 0, and 1. In order to graph it, I'm going to review this real quick. We made an xy table. We put our domain values, negative 2, negative 1, 0, and 1, on the left-hand side, and we found the y values on the right-hand side. So we plot our points, negative 2, negative 3, negative 1, negative 1, 0, 1, and 1, 3. We didn't connect the dots because our domain were these independent little points. Now we're going to change things up a bit. Suppose you were going to be asked to graph, or to do the following. Graph the following function and find its range. Y minus 2x equals 1. Our domain is no longer a series of values. It's not just 1, 2, 3, 4, and so on. Notice that our domain are all of the x values that are between 0 and 2. And then we have to find the range. So what's different between this and the previous example? The answer is that y is not a function of x. So we'll need to rewrite the equation. Second difference. Before we were given the exact numbers to put in for x. This one's a little bit more complicated because we're going to have to choose the values to put in for x. Thirdly, there's no graph given, so we're going to have to make our own. And the fourth point is it asks us to find the range, so we're going to have to actually graph and then figure out what the range is based on that graph. So let's go ahead and graph the following function and then find its range. The first thing we want to do is to make sure our function is rewritten so that y is a function of x. That means we've got to get y by itself. To do this, I'm going to add two x's to both sides. This gives me y is equal to, since the negative 2x and 2x canceled, positive 2x plus 1. Now that I have y as a function of x, I need to make a table like I did in the previous example. Or rather, previous types of problems we worked. So I'm going to make an xy table, but I'm going to put a process column in between to help me keep track of my work. This is a bit tricky. What x values do you use? X is between 0 and 2. Well, you just start with your smaller number of your domain, 0, then 1, then 2. Can x go any bigger than 2? Well, the answer is no, because x has to be between 0 and 2. So now that we know the x values, let's find the y's. 2 times 0 plus 1. That gives us 1. 2 times 1 plus 1 gives us 3. 2 times 2 plus 1. That gives us 4 plus 1, which is 5. Now that we have our x and y values, we can actually graph it. My x is 0, 1, and 2. My y is 1, 3, and 5. So I'm going to go 1, 2, 3, 4, 5. And then we can plot our points. 0, 1, 1, 3, and 2, 5. Now, unlike the previous types of problems, our x's can be any number between 0 and 2. This means that when we graph our points, they can be any value between the smaller and the larger points, and it actually ends up creating a line segment. So, when graphing a function with a domain that's between two values, you end up with a straight line segment, not just a bunch of points. What about the range? Well, your y values start at 1 and they end at 5. Notice, the y values don't go any lower than 1 or any higher than 5. So we can write the range in the following way. We're going to put a 1, because that's our starting value. We're going to put a 5 over here, since that's our ending one. And we know our y values have to be between the two. Your symbols will always point in the following directions. And briefly, I'd like to explain why. Notice that the y values are always less than, or are always smaller than 5. Is that true? Well, yeah, y value goes smaller than 5. Y value goes from 5 to 1. Well, what about the 1? This tells us that the y values are on the bigger side of the symbol than 1, which means y is bigger than 1. Are all your y values bigger than 1? Well, yeah, because it goes from 1 all the way up to 5. Those are numbers bigger than 1. So, when writing your range between two numbers, you write it in the following way. Y in between, the first number on the left-hand side, the larger number on the right-hand side, and these two inequality symbols in between. Go ahead and try this problem out on your own. Press pause, work it out, and when you're ready to see the answer, please press play. Alright, I went ahead and got y as a function of x, and there were a lot of values to find out. I'm going to show you a trick here in a second to shorten your workload. Then you started making a graph. So you got y by itself, or y as a function of x. You wrote your x values in a table, you found your y values, and now you're going to start making a table. X was -4, -3, -2, 1 and 0, and your y values go up to 22. I don't really want to count all the way up to 22, so I'm going to choose to count by a slightly larger number. I'm going to count by, let's say, 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Now you can count by whatever number you choose to, so long as you signify that on your graph. If you're counting by 1s, it's not necessary to show it, but I'm going to go ahead and show it just in case. Okay, -4, 22. I'm going to skip all the way down to 1, 7. 1, 2, 4, 6, and 7's in between those two values. Now, if you plotted all the points in between, you would have ended up with a straight line between -4, 22 and 1, 7. The reason for that is because what we were given was a linear function. Y equals some number times x plus or minus some number. A linear function always creates a line, and in order to graph a line, all you really need, and I know it's like you're showing me this now, right, is the starting and the ending points. You only need 2 points to make a line. So actually, you would have only had to work out the first part of your domain and then the second, and connected those 2 points with a straight line. Let's find the range. Notice your range goes from, this was 7 on your range, all the way up to 22. So you wrote that as 7 and 22 over here, y in between, using our two inequality symbols to put y between the 7 and the 22. And there you go, you've graphed the linear function and listed its range. I've got a couple of exceptions to the general way of graphing I'd like to show you. The first one is y is equal to x plus 1, and our domain is x is less than or equal to 5. Notice that x isn't between two values. It starts at 5, and x has to be every number smaller than 5. So 5, 4, 3, 2, 1, 0, -1. And we're going to try to find that last endpoint. The problem is you'll never get there because x is every single number less than 5. In this case, to make graphing easier, I would probably choose 5, our starting value. Notice x is less than or equal to 5. And then I would choose 0 because that's where our graph is going to cross the y-axis. Let me show you. If x is 5, 5 plus 1 is 6. If x is 0, 0 plus 1 is 1. So when I graph this, I've got x is 5, 1, 2, 3, 4, 5, and y is 6. If x is 0, y is 1. Now when I graph this line, my question to you is, where does it stop? Notice I'm going to start at x being equal to 5. How far does the line go down before I actually get it to stop? Well, the x values go on forever in the negative direction. So I'm going to put an arrow showing that the line's going to go forever to the left. What's your range then? Well, notice your y values start at 6 and then they get smaller. So we're going to say our y values are less than or equal to 6. And there you go. Now I have one more exception to show you. Suppose we were to ask just to graph the following function and you weren't told any domain or range at all. What would make this one different from the previous ones? In our previous one, we had a restriction. X was less than or equal to 5. In this one, we weren't told x had to be anything. So guess what? It goes down forever, to the left forever, but it's also going to go to the right forever, which means your range is any y value. And when your domain or range aren't written, it's just understood that they go on forever in both directions. And now we have two special graphs. If you try to fill out a table for these graphs or make y as a function of x, you're going to have a really hard time because, well, there's just a y value. And again, these are two different problems, and over here we have just an x value. As a graph, y equals 3, 1, 2, 3, is just a straight line through 3 on the y-axis. Because no matter where the line goes, the y value is always 3 for that line. Now the x value, well, it can be anything, because you weren't told x was anything at all. So x can be anything, but y is always 3. What about x equals -5? 1, 2, 3, 4, 5. What line can you draw to go through x is equal to -5? The answer is a vertical line, straight up and down through -5 on the x-axis. These are special graphs because, again, you don't have two variables, you just have one. And y equals always creates a horizontal line. X equals a number will always create a vertical line.